I live for somebody to tell me you can't do that, it'll never work.
But you wouldn't be crazy to wonder if sending a robot to refuel an operational spacecraft might run that risk. But you know, engineers have imaginations. Consider this. Every satellite flying right now is bespoke, hand-wrought, customized, detailed, and extremely expensive. That's why it pays to figure out how to repair and refuel the things rather than just replace them. There's just one problem. That's hard to do.
Just getting the robot to go where you want it to go, they don't position precisely. So you have to do things like build lead-in into the tool. An astronaut could probably just get it right on there because he's right there.
Just like performing at Carnegie Hall, satellite repair missions demand rigorous practice. And the big practice session on deck is called Robotic Refueling Mission, or RRM. At Maryland's Goddard Space Flight Center, mission planners use a motion simulation platform to figure out how to get all the parts working together. When a robot arm clips a wire this fall, it'll be one small snip for robots, one giant leap in the business of space-based satellite servicing. The last space shuttle flight delivered hardware looking a lot like this right to International Space Station. It's a box of practice equipment, a busy board of valves, nozzles, clamps, and more to simulate the side of an actual satellite. A Canadian robot called Dexter will interact with the practice gear. It's different in space than here on the ground, but that's kind of the point. The whole thing is a learning experience, a big one.
We're showing folks that we have the capability to use an existing robot that was not meant to be used with tools to work on RRM, and we've adapted those tools to make them compatible with the Dexter robot and also compatible with our Mach satellite interfaces that we have on RRM.
The robot is a very stiff, rigid interface. It's not forgiving like an astronaut's hand. When you push on something really hard with the robot, you build up really large contact forces. When the astronaut pushes on something, his wrist might give. He's got his own internal sort of software compliance running.
Station astronauts won't be involved. This will be a mission run from the ground. RRM will demonstrate a number of essential tasks. At the end, it'll attempt a first-of-its-kind simulated fuel transfer between two pieces of hardware. Not so easy when you're orbiting the planet at 18,000 miles an hour.
It's really exciting to feel like you're working at the front of the wave. And the work that our team is doing it's uncharted territory.
The robotic refueling mission augurs a revolution in spacecraft operation and design. It may be a rehearsal for bigger things to come, but it's also a direct expression of a space agency with big ideas.